So I'm going to go ahead and get started. For those of you who don't know me, my name is Bob Thompson. I'm an associate professor, research professor at the University of Michigan. My area of expertise is theoretically in the brain. I have operated a basic science research lab at the University of Michigan for the better part of the last 20 some years. And looking very much forward to retirement very soon. And I tell you that not so much because I think I know anything more about the brain than anybody else in the audience or anywhere else on the planet for that matter. But I think I know enough to be dangerous, is what my phrase is often used. And Pastor Jim had approached me some time ago, as he often does, with this idea about trying to talk about how faith changes the brain. And instantaneously, I got very nervous because he handed me some information. And like a good scientist, my immediate attention was drawn to who was the author of the particular work that he had heard about. And not only was this individual not a scientist, but they were some sort of author that theoretically read a lot about science and the brain, and was yet espousing about how faith was influencing the brain. And I tell you that story a little bit to sort of try to make 2 points. One is that just because a message comes from somebody who may not have a particular expertise doesn't make it wrong. And I think that's a really important thing to keep in mind. Particularly people, as people of faith, I think it's really important to have open minds about all kinds of influences in our lives. But yet at the same point in time, I think God gave us a brain to actually sort of explore, sort of details, if you will. And we, if nothing else, at least in America, we are a detail-oriented country. And as individuals, I think of myself as very detail-oriented. And so that's where the idea was born. And so I thought I'd give you some vignettes today. And then at the end, I'm going to share an opinion with you. That is part based in science, but mostly, I hope, based upon my faith as a Christian. And so I thought I'd start off by just showing you this video that hopefully, or some of you may have seen on a popular...
Your brain is an amazing thing, but as you get older, it naturally begins to change, causing a lack of sharpness or even trouble with recall. Thankfully, the breakthrough in Prevagen helps your brain and actually improves memory. The secret is an ingredient originally discovered in jellyfish. In clinical trials, Prevagen has been shown to improve short-term memory. Prevagen, healthier brain, better life.
Okay. So I show you that to sort of, and again, if you're interested in the website, that's the website for that. So is there anyone who has not seen that particular commercial?
I've seen it. No, it's there.
Yeah. So again, I think as a scientist, those kinds of commercials, drive me crazy. Because if in fact you start digging into the clinical details, those clinical studies that they refer to, 2 of them are actually really bad science. There's not an adequate control group. The first 2 studies didn't control for what's called a placebo effect. That's essentially, an effect where I try to convince you that something's going to happen, but it's not. There's no basis for that to actually happen, but yet you believe. Sound familiar? And so as a consequence, you are convinced that something I give you or do to you is actually going to work, regardless of whether in fact there is any effectiveness. When I first think about those kinds of things, I'm reminded of a MASH an old-fashioned Army MASH, TV show with Alan Alda and such. That's been gone for many years. And I think in that particular story, they ran out of morphine to treat patients. And so they were struggling trying to figure out what they were going to do to actually, manage pain, post-operatively. And what they did is they used ice packs. But yet at the same point in time, they were giving, their patients sugar pills and telling them that it was something a lot like morphine, but it was more powerful. And in 2/3 of the people, it actually worked. Simply because a doctor, a knowledgeable individual, gave them something that said, this is going to help you manage your pain. And they call that the placebo effect. In psychiatry, it's actually a really big deal that you control for those kinds of things. The third study was really relatively small that cited. It's not been replicated despite the fact that it actually occurred many, many, many years ago. And in fact, the FTC has actually gone after this company for false advertising.
So you cringe quite strongly when it started playing in there.
I always thought it was interesting that they make a big deal that it's originally found in jellyfish, because we all know how intelligent jellyfish are.
I'm sure we've all seen them on the beach, helpless to get themselves off the beach, if only they could walk, right?
It's a good visual, I guess.
Yeah, and again, if you're ever interested, information is never bad. You can actually drill into details and learn what's knowable out there. There is a particular logic, if you will, to what some of these supplements do. In this case, it actually is a protein called aquaporin, and it's thought to be a calcium binding protein, and calcium is really an important mineral found in the brain. Neurons rely upon calcium and calcium release inside neurons to function properly. But there's no evidence whatsoever that says if you take this protein that's normally found inside cells and actually just ingest it, that it actually does anything in the brain. There's no evidence to suggest that it does. Now, I'll come back to you in just a second.
Okay.
The current legal battle between the FTC and this company is stuck because the judge in that case said that the FTC was not able to prove that this agent doesn't work. So that's where that stands today. So it's not so much that this company has to prove that it does work, but rather the FTC has to show that it doesn't. So anyway, and there's I saw one last night. What was it? Neurotin or something like that. And again, it's a concoction of various herbal supplements, but the most prominent, and it's marketed as improving attention, improving memory, kinds of things. And you know what the most active agent in it is? Oh, I heard it. Caffeine. Yeah. I was going to grab my coffee cup. And so imagine, you're hyped up on coffee, kind of thing. Imagine that. It improves your attention simply because you're more alert. And it's been known for decades that caffeine has these kinds of effects. And the way you find out about that is, again, drilling into the details. But also, if you look at the information found on that company's website, they notice that there's a disclaimer about side effects. And one of the side effects is that if you take this for multiple weeks and you stop taking it, guess what? You undergo withdrawal effects.
Yeah.
Imagine that. Anybody who's ever tried to stop drinking coffee, if you're a coffee drinker, you understand what withdrawal effects are like.
It's Nariva.
Yeah.
I looked it up.
Nariva?
Nariva.
Yeah. Okay. So, I haven't actually read these slides. So, again, there's lots of evidence out there to suggest that, all kinds of things in our lives affect our brain. And for me, as a scientist, I need to understand sort of what effect means in that context. Everything we do in life affects our brain. Sure. Everything. You know, unfortunately, as you're sitting here, you're changing your brain. If you remember the fact that you even walked in the door, if you just remember that one thing, you have changed your brain. Because that memory is got to be stored somewhere, and that is stored not in your foot, not in your heart, not in your lungs, but in your brain. And so whether you learn anything else, from, this discussion today, you are constantly changing your brain. And so again, in my little paragraph that I put out talking about, we've all seen, things that are supposed to change our brain. Diet, sleep, exercise. And they all change your brain. And remarkably enough, in many of these cases where scientists do so-called clinical studies of trying to understand where and how our brains change in response to these things, inevitably, the same locations show up over and over and over again. And much of the debate in the scientific field is trying to figure out, one, why is that the case? And what does that mean? And we don't have really good answers for that. And part of the reason why that's the case is due to technological hurdles. We're trying to understand a structure that by its very nature is designed to change. Because if it doesn't change, that's maladaptive to our daily lives. If we can't learn on a daily basis, that's maladaptive. Look at even modest cognitive decline in our elderly and ask them about how that influences their daily lives of not being able to remember, where did I put my shirt? Did I take my medication? What time is it? What day is it? What month is it? All those kinds of things can have profound influences on them, their personalities, and certainly their brains. So we are required, almost as a species, to be adaptive, and that requires change. Again, if one wants to spiral into the molecular details of exactly what that means, we would need months to actually sort of talk about that. But I just sort of put up, various kinds of things that talk about the spiritual brain. I'll just read through a couple of them. Meditators and multiple individuals with extensive religious experience have drastic changes in your brain. I have no doubt that that's true, but compared to what? And what are these drastic changes? It makes it sound as if, one person's brain is really tiny and the other person's brain is really big. And I assure you that's not true. And I'll show you an example of that. And they talk about one of the factors is asymmetry of a brain region called the thalamus. The thalamus is a brain region through which all sensory information is processed, except for one sense. Do you know what that sense is? Smell. It's thought to be our oldest sense. And we talk about relay areas. We're talking about relays between the outer environment and our cerebral cortex. Our cortex is what most scientists believe is the places where we know things. And so that all other sensory modalities are processed through the thalamus. And so why an asymmetry would occur in the thalamus is kind of intriguing. Because if it's a sensory relay places, this is a way one might argue that the brain can control how the external environment gets filtered before it gets to the cerebral cortex. So if there's asymmetries there. Unfortunately, what happens in this case is they'll show you images, and I'll show you a couple examples here in a second, where one side of the thalamus is different than the other side. And that lack of symmetry, if you will, has no known origins, to the best that we know. Okay. Meditators who practice loving kindness have hyperactivation This is in the lateral prefrontal cortex. That's an area sort of up in this area of the brain. I was going to bring a brain in today, but you laugh. I was going to do that. Integrated stepwise relationship hours of meditation relate to increased thickness of, again, the prefrontal cortex. Prefrontal cortex is thought to be an area of our brain that we use for making decisions, where we, some people have thought of this as sort of our moral compass, area. And some of these notions are based upon lesion studies, where people have, been in a car accident or had a tumor, and that particular area of the brain gets damaged. And then we look at those individuals after the fact and we ask, well, what's different? Nowhere else in the brain, but in the brain, are those types of analogies good and horrible all at the same time. Because the brain is so interconnected, or brain parts are so interconnected to each other, that loss of one of them, one of these areas, can dramatically influence all kinds of functions within the brain. And so we have to be really careful about saying, this area does X, this area does Y, and so forth, because it's rarely that simple. Okay, I don't want to belabor that. There's all kinds of, again, this is a study that a author who's at a very prominent university gets talked about. So this is an example of 40 participants, including Christians, Muslims, Jews, and Buddhists, showed the same areas lit up, and I'll show you how they do that, when they were asked to ponder religious and moral problems. So again, imagine these individuals are in a special type of imaging machine, and they've been given a drug that allows the investigator to look at what parts of their brain are active. And so they put them in there, they ask them benign questions, what's your name, where do you live, things to try to collect a baseline activity of your brain. And then they ask them more specific questions, supposedly things related to religious or moral problems. These studies are both really interesting and really hard to control for. But in essence, they looked at these types of differences and found a particular area. This is Brodmann area 21. It's a middle area of the temporal cortex, which is part of the side area of the brain. So this would be roughly the frontal cortex. This is what's called parietal cortex. This is occipital cortex. This is temporal lobe. So this is like a side view of the brain. This would be your cerebellum, brain stem, and spinal cord. Just to give you the eyeball would sort of sit like here. I've drawn a few. Okay. Okay. So I have a series of a few videos I'd like to show you. Okay. Some of them are interesting. One of them is.
Hopefully, all of them are interesting.
Yeah, I hope so too. I'll try to read it. Exciting new research sheds light on the mystery.
It's a mystery.
A neuroscientist, Dr. Andrew Newberg, writes on how God changed your brain. The moment we encounter God, or the idea of God, I've lost it already. Here's how. Okay, so these are some of the imaging studies that I was telling you about. So these are cross-sectional images, as if you're going from, in this case, the bottom to the top of the head in the horizontal plane. I can't really tell exactly what kind of images these are, but they look like MRIs. And so this is very far down in the skull. So we're just starting to see aspects of an opening in the skull. Anything white is typically bony. So that's actually our skull. And so there's a big hole here at the base of our brain. It's called the foramen magnum, and through which the medulla oblongata goes into the spinal cord and exits the skull into the spinal column. And so you'll notice that eventually you start seeing this lobus structure, that's the cerebellum. And you start to see these components here, that's aspects of the temporal lobe. Imagine a slice that goes through there. And then as you proceed higher, you start seeing more and more of the brain. That's this gray looking stuff. These V-shaped types things are the ventricular systems through which cerebral spinal fluid is produced. And they essentially collect these types of images across the entire axis. And then they have ways of quantifying activity in these areas. And again, I don't want to, if you're interested, I'd be happy to go into the details of how that works. But the general notion is that they have a drug that they can monitor outside the body because it yields energy, special energy. And that energy is enhanced or collected inside cells that are really active. So the more cells that are really active have more of this energy, and hence it's detected locally. So imagine it, this is a way of, having a 500,000 foot view from the sky, where someone up there with their drone can look down and see who left the lights on in your house. Okay, so the more lights you leave on, the easier it is for them to see. So this is, this is from Dr. Newberg, who was cited multiple times in that most recent video. And I forget where he is. I think he's at Penn or somewhere in Philadelphia. Although he could be in New York too. I forget. There's a sort of a mindfulness institute at either Penn or Harvard that's really quite well known. But this is an example of one of those activity measures. And again, it's a horizontal slice through the human brain. And in theory, they do this in a lot of people. And there's ways of combining those images in similar brain regions to sort of get a net or a group set of images for those that are on the baseline and following, in this case, prayer. And so in this analysis, he's drawing your attention to this area here, which is in the prefrontal cortex, loosely defined, that is redder, which is in his analysis thought to be more active when people are engaging prayer than under baseline. And again, this is a similar type of comparison between people who are just singing while then they're in the scanner versus speaking multiple tongues. And again, I don't really see much of a difference between these two things, and certainly into the areas that are here, I think this is supposed to be quieter, but again, I must tell you that this is considered state-of-the-art methodology today. And that's both the good news and the bad news. So one of the slides I was trying to get to work that I couldn't is to try to show you a slide that a good friend and colleague of mine uses to try to give one a sense of the perception of scale. And it's important, particularly when we think about how the brain functions, to understand scale, because many of the types of things that neurons do occur at very, very tiny levels. But you know, that's an interesting word, but it doesn't have much context to it. So what does tiny actually mean? And that's what this one demonstration that I couldn't get to work, tells us. But maybe a loose analogy is that, since I've already introduced the sort of the 50,000 foot hovering unit to sort of measure lights in our houses. But really, what if lights in our houses aren't really the appropriate measure? Well, what if we need to actually measure where people are? Or what if it's not just we need to know where people are, but what it is they're doing? And what if it's not so much we need to understand what they're doing, but whether they're writing with their left or right hands, or whether in fact they're holding their pencil, like this or like this. And so those are sort of concepts of scale. And I tell you that because this particular technology is so anatomically crude that it's measuring millions of neurons in some of these areas. And it is highly likely that in fact many complex human functions occur at much, much smaller scales, involving vastly smaller numbers of neurons. And I'll give you one tiny example. Tiny example. And so our reproductive systems are governed by a set of neurons found in an area called the hypothalamus. And in the female, where we know a lot more about reproduction, or what drives reproductive cycles rather, much better than we do anything else. And those in the human, those reproductive cycles are governed by 900 neurons found in the hypothalamus. And this would be akin to taking the entire state of Michigan and analyzing 900 rooms that are scattered somewhere in southeast Michigan. If you do not have those neurons, you will not have reproductive cycles. And so, amongst the millions and millions of rooms that are found within the entire state of Michigan, female reproductive cycles are governed by a relatively small number of places. And yet, if you don't have those rooms lit up or working properly, you will not have reproductive cycles. And so if your technology is only capable of looking at cities, how will you ever find those rooms? I can tell you, you won't. And again, that is not a criticism of the science, because the science that they're deploying is literally state-of-the-art. I mean, no one would imagine 20 years ago that we'd have been able to look inside any living, alive, breathing, talking, individual. But we can. But it's just that the scale is just not proportional to the questions that I think we need to answer. Okay.
Concentrating on a prayer, the Buddhists who were focusing on an image, they all activated their frontal lobes. And that's exactly what you did too.
If I was contemplating the image of God, could you tell the difference?
We actually scanned an atheist who was a very good meditator, and we asked him to concentrate on God, to meditate on God, and he wasn't able to activate his frontal lobes very much. So in fact, if anything, as you can see, that sort of decreased a little bit, yeah. So even though they said, yeah, I'm concentrating, I'm trying to contemplate God, they just were not able to do a very good job of doing it because they didn't really believe it.
That's
so I think part of what that told me is that regardless of what our practice is, the key is do you believe it? Do you buy into it? Is it important to you?
It's amazing that somebody came up with the idea that you could shoot somebody full of radioactive drugs and look at their brain.
The brain is just so unbelievably complex that it's not that there's one God spot or one God part of the brain, but it seems to be the whole brain that gets involved. And ultimately, these change the way you think and feel about the world.
So apparently, it is possible to see physical manifestations of God inside us. Whether you're Christian, Buddhist, or any kind of spiritual person, experiencing the divine actually changes the brain, changes the way we see the world. That's pretty something.
Actually, I'm going to go ahead and skip over this. Before I do that. Okay, so I'm going to jump into my opinion area. So, I think it is true that, all sorts of life experiences change our brain. And for me, my faith life, my, experiences that I have during worship or as a Christian, I think change my brain and change who I am. I believe that, till the end of time. I can't prove it. And I would argue that, in fact, if I am open to the notion of faith active in my life, I don't need proof. Because if I have proof, for me, there's no faith. If I have overwhelming evidence that, in fact, this occurs, where does faith then live? And so I don't need science to actually direct me in that regard. So almost by definition, faith is something I cannot prove. And so it doesn't bother me. I don't wrap my mind around it too much, whatsoever. And this type of effort to prove or seek scientific evidence for such a thing, to me, feels like a waste of time. It's a poor use of scientific intellect in many regards. Now, I can understand why people are curious. And again, I'm a very curious individual. It's what drove me into science in the first place. But at the same point in time, I don't necessarily need to actually pursue these particular types of research questions. And part of the reason why you'll see me shake my head on many of those kinds of things is if you drill into Dr. Miller's research, they often involve a relatively nominal number of individuals that go through these scans. These scans can be horribly complex. They take long periods of time. Getting volunteers to actually sit in a scanner for hours on end, is not an easy thing to do. And so it's not like everybody on the planet is saying, yeah, do me. And they're horribly expensive. They can cost thousands of dollars per patient. So imagine, you're trying to, get NIH or some similar entity to fund these kinds of things. You're not going to be able to do thousands of these people. You won't get the volunteers, and you won't have the money to do it. And so almost by definition, the research studies are somewhat underpowered in terms of numbers of patients. And I particularly despise the individual patient comparisons that he did in that one thing where he said, well, in this particular individual, there was one, oh my goodness. You know, an N of 1, given that how many billions of people that we have on this planet, and you don't have to look around the room very hard to see that we're all a little different. And our brains are probably equally different. How each of us processes information, how we collect information, how it proceeds through our brains is different. And so to use individual comparisons like that, I think is really just, it's not based upon good science. And so, but again, I'll come back to the point I made at the very beginning, that just because, you know, that is not good science doesn't mean that it's untrue. It just doesn't mean that we've sort of have evidence to support that particular idea. Yeah.
It's interesting though that individuals' stories and experiences, when you hear someone talk about their experience, think that can be impactful. You know what I mean?
Sure. Well, again, we are creatures that are brought up through thousands of years that rely upon the impact of storytelling. And every time we hear a story, whether we're paying attention or not, we are changed as a consequence of that. So when you first were starting talking, I thought you were going to say something different. And that is that, you know, for people who have had various types of religious experiences, that they often report similar types of things. And again, that is true. But the problem is that once I hear what somebody else's story is, there's no way for me to walk away from that. And so I walk into now telling my own story biased because I heard what somebody else experienced. Now again, I'd like to think of myself as reasonably objective, and so I could try to parse that, but at the same point in time, again, there's really good research to suggest that that bias persists. So my own story is now biased because I heard somebody else's story.
One other thing, something that comes to my mind is, you know, the pictures of the drama pictures, like happy and sad. I saw a cartoon once. It was the drama, and one person is looking at it saying sorrow, sadness, and the other person is looking at it saying material, like this is giving something to work with. So it's interesting how you can see the same exact thing. You're talking about being impartial, or you can see both people are seeing the same thing, but they're thinking different. They're interpreting it in a different way.
Yeah, again, there's lots of good research studies about what we pay attention to when we see something. And again, you know, even though we'd like to think that that's really simple, you know, when you look across this side of the room and then you look over this side of the room, if I now had to sort of, you know, retell who's sitting on that side of the room and where, even though I just looked there, I couldn't do it.
Yeah.
Now, yet somebody else could do that, and maybe they'd be, you know, get half of it, or, you know, but there'd be lots of variation associated with it, and that's because I was paying attention to my beautiful wife in the background, whereas somebody else, you know, would be drawn to something else, you know, kind of thing. And so, but, you know, that ability to either lack attention or have different levels of attention to detail, you know, is a skill. And it's unfortunately, it's not a skill that all of us have perfected. And it, you know, it's like everything else in our lives, it varies. So, you know, so on one hand, I truly believe that we are constantly changing our brains. I think there are ways that you can have positive effects on those kinds of things. Some of these supplements may actually be useful to you. If you have a poor diet, if you do not have, you're not able to or aren't sort of able to practice various levels of exercise, if you have, say, a less than positive social structure or social environment, you know, you may find some of these, you know, supplements, you know, useful. Is that the norm? I have no idea. And I don't think the company does either. So again, I tell you that in part because you will hear anecdotal evidence that says that, well, I took this, man, I could jump out of bed, I could remember 12 things before I had my first cup of coffee, kind of thing. I can't do that, but that is not scientific evidence to suggest that it's that agent, because I could have just as easily given you a sugar pill, and you may have had exactly the same response. But in some people, you may actually have some sort of, consequence. Yeah.
One of the best cartoons I ever saw was doctors sitting with a patient in front of them, behind the desk, and the patient is saying, "Doctor, I think I need a stronger placebo."
Yeah. Well, the power of suggestion is really not to be discounted. So are there various kinds of things then that we can do to actually influence this process? And again, I would argue that the answer to that is yes. Again, in a very biased, very opinion-based, non-scientific, we can be practicers of our faith. Think of it as, our Christian exercise. And so, people that are, who practice empathy are more empathetic. People who practice love are more loving. And so, again, many of these kinds of things shouldn't be very surprising. But it's really about getting those Christian tools out of our toolbox and actually deploying them that actually are what enriches us, I think, as a species. We need to eat better. We need to exercise more. We need to sleep better or sleep more. We need to manage stress. Again, one of my theoretical areas of expertise is understanding how at least chronic stress alters the brain, and more specifically, how different neurons in the brain are actually modified by stress. And what does that even mean, modified? If I say a cell is experiencing stress, what does that mean to that cell? How does it alter its function? And that cell exists in some sort of circuit diagram within the brain. What does it now mean to that entire neural circuit if that particular neuron is not behaving properly following stress? And we all understand that, in fact, stress is really a bad thing. If you're stressed before you take an exam, you're not going to do very well on that exam. Yeah?
Well, if you are pursuing this research about stress in the brain, which I think is really important these days for a lot of people for a lot of reasons, do you have any preliminary findings, or is it all still kind of amorphous?
Yeah. So I've been studying stress in the brain for, let's see, I started graduate school in 1984. Yeah. I think what we've come to understand is that stress is not stress is not stress. So that there are different types of stressors. There's emotional stressors, there's physical stressors, there's psychological stressors, there are hormonal stressors. And so we have to be really careful about just throwing out, lump all terms, because they're not the same thing. Chronic stress is also not the same. Chronic stress, to me, could be something that you would brush off in a moment. And so there's a very much an individual component to that. Because if I perceive it to be stressful, I will be stressed. And if you've been through this exact experience and said, what's he worried about, kind of thing, he won't find it stressful. His body won't respond, as if it's under stress. And so, prior life experiences will have influenced sort of what that all means. Having said that, based upon various psychiatric studies that have targeted different brain regions as more or less dysfunctional in various psychiatric diseases, most importantly like depression and bipolar illness. there are certain brain areas that are thought to be more dysfunctional than others. And within those brain regions, my lab has studied a particular subset of neurons that are thought to control within brain region neural activity. And we've spent the better part of the last 20-some years devising tools to allow us to isolate those cells to the exclusion of all other cells. And so again, this is analogous to finding ways to separate those 4 rooms, or those 900 rooms that are scattered across southeast Michigan from all the other rooms in the entire state of Michigan. The good news is that we figured out a way to do that. And so we're now studying, or trying to devise ways of answering the question of, well, how are they now changed as a consequence of stress?
So you're really laying the foundation for future research.
Well, I'd like to think so. I wish NIH thought so too. And actually, a good reason why I'm closing my lab, or have closed my lab, is that I wasn't able to convince NIH that that was a worthwhile activity. I think they're wrong. Let's see. So we're going to eat better, we're going to exercise more, we're going to sleep better, love more. We're going to practice our faith. All those kinds of things. They're all nourishing activities. And at the same point in time, we're going to try to, as best as possible, manage negative things in our lives. Try to manage stress, develop coping strategies. So in the field of stress research, there's as much interest in trying to understand stress, but also in trying to sort of develop what we call resilience to stress. So maybe it's not so much that, maybe it's normal, whatever that means, to actually experience stress and have, be stressed out, if you will. And what's abnormal is actually to be resilient to it. And so it's sort of the flip side of that question. And so, maybe it's actually good for the species to actually be resilient to these kinds of things. Those might be the individuals who survive in a highly stressful environment that perpetuates for any length of time. So that again, I had some jokes at the end. So this is an analogy of, it says, in a deformed Republican capitalist brain, areas that normally control life-sustaining processes, the guilt gland, the envy center, or everything for a free lobe, are miniaturized, while other regions become bloated out of proportion. The personal responsibility lobe, the self-interest cluster, or the overdeveloped inflexible spinal cord that is connected to the absolute morality lobe. Again, I just found this sort of interesting. And again, just to be equal partners, here's the socialist brain of a liberal Democrat. And it says a liberal brain is known to have a well-developed blame America synapse, a benign smarter than thou tumor, a global warming panic center, the entitlement synapse, moral relativity gray area, and the PC lobe, responsible for speech codes, multiculturalisms, racial quotas, and alternative lifestyles. The underdeveloped areas of a liberal brain usually include those that handle common sense, personal responsibility, sense of humor, patriotism, and work ethics.
Awesome. Are we friends on Facebook? Can you post that? Both of them.
It is interesting, but those same types of neural imaging studies that Dr. Martin used have been used to look at conservative and liberal brains.
Oh, yeah.
And again, I can't recite the literature verbatim because it was a long time ago, but I talk about it in my neuroanatomy class some years ago. And one of the areas that was shown to be different in terms of activity was the prefrontal cortex. And the notion was, I'm trying to remember how this worked. I think in the liberals, that particular brain area was quiescent, and in conservatives, it was much more active. And they used it to basically support this notion, as much as we laugh about it, that there are certain brain areas that are different. And again, that really should not be any surprise at all. I know my children, are brought up in a highly liberal home environment. Mom and dad talked Portuguese that was their word for science, around the dining room table. And we talked about all kinds of social, kinds of things. And so my children grew up in an environment, and why would we anticipate that growing up in that particular environment would have no impact upon them as they grew up? It would be like anything else. We teach them, how to read, we teach them how to behave, the concepts of good and bad, we pray that in fact they integrate those kinds of things into their lives. And so these other types of things would also sort of manifest themselves. And so notions of things that are, maybe slipping down the slope of conservatism or liberalism might have some sort of change in their brains. Praise to God. So I'm open to any kinds of questions, but that's pretty much what I had for you today. So hopefully I've convinced you that you've all changed your brain today, and that's a good thing. I hope you change your brains every day. Every day. Because when it stops, that's a bad thing.
Yeah.
Yeah.
I just want to say that I really appreciate the fact that you and I, so you as well, are both brain researchers, and that you bring your whole selves into it with faith, all the package, the whole package. And it just reminded me that some years ago, I was asked by the National Association for Research on Schizophrenia and Depression to interview a local hotshot researcher. And I will never forget, he and his crew were charting the brain, and they were determined that once they had mapped the whole thing, and he had a map, that he was going to solve all the problems. It was so reductionist, it just terrified me. And at one point, I said, "Well, what about faith?" And he said, "We're very close." I went out of there, and I was just shattered. And then I thought, no, he's never going to find my faith.
Yeah.
but
Was that Narset?
Yeah.
Yeah.
Yeah. So I'm just curious, what's it like for you to be in an environment that's very generally, I think, very clinical, very reductionist, very Skinnerian,
I've not walked anywhere else. I have my church home, but my church home goes with me no matter where I go. I don't separate it. And at the same point in time, it's not like I've operated in other types of corporate, environments. My mother, when she was alive, used to ask the question, "Aren't you ever going to graduate from college?" Because I simply went from college, to working in a university,
Right.
to being a graduate student, to working at a university, and I'm still at a university. And so she never understood that, in fact, you were employed there, kind of thing. And so, but Mom was a little, she thought I was an exterminator. Because I worked with lots of mice and rats. And I could tell her how we could take the brain out and study it, but she noticed very quickly that we weren't putting it back in. And so she would tell, her friends that, in fact, my son, I was known as Rob or Robbie, would basically kill mice and rats. That's what I did for a living. Yeah.
I'm a biologist, and at one point I was asked by someone, "Well, how can you be a scientist and believe in God?" And I said, "How can I be a scientist and not believe in God?"
Yeah. So again, feel free to get up and leave if you have to. By all means, I understand worship is starting to take place. But I concur. I once taught a Sunday school class, it must have been at least 10 years ago here, on the intersection between science and faith. And my mantra for that class was, how do you know what you think you know? And I bet you I could push virtually any scientist to the point of sort of a gap in knowledge, where now they had to actually have almost a leap of faith to actually move forward in their daily life. Now, again, we don't think in scientific terms like, deploying faith. That's not very scientific. But we do develop hypotheses based upon things that we think we know that allow us to move into the unknown. And so, as a consequence, I am not the least bothered by what I don't know. Because if I was bothered by that, I couldn't ever do my science. Because if I'm doing science to do something I already know, then why did I bother to do it? If I already knew the answer, that doesn't make any sense. So almost by definition, I have to be, emotionally, psychologically prepared to move into the unknown. I also have to be equally prepared to fail, because I will fail 99% of the time. And again, I think Thomas Edison had some kind of famous quote, about like making the light bulb or something like that.
Yeah.
Something about,
I've only discovered 10,000 ways to don't
not do it.
Yeah.
I only had to be successful one time or something,
Yeah.
kind of thing. And I think that is true. And that's how, science moves forward.